In this video, we are going to be looking at circles. So circles are my absolute favorite shape. They are beautiful, they're fascinating, and they have a lot of interesting characteristics. So we're going to be exploring them in depth. All right, so for this video, you're going to need a couple markers, a couple different colors. You might want a ruler or a straight edge to draw some straight lines. And we're going to be going through, first of all, the anatomy of a circle. So what makes up a circle? So a circle starts with a center point. So go ahead and draw a center point in the circle here. And then that circle or that center point, imagine that there were to be a line that extends out from it to a given distance. And then that point were to rotate around that center, always maintaining the same distance around. That then is how you would make a circle, which is pretty much how a compass works. So we're going to go ahead and label some key features of a circle. So first of all, a circle always starts with this very complicated vocab word, the center. So the center of your circle. All right, now if we take any point along the edge of our circle and we draw a straight line through the center all the way to the other side, so go ahead and make this line, we have now made what is called the diameter of the circle. The diameter of the circle is just the measurement that goes all the way across your circle and through the center. So it is the longest distance within that. Any other point along the edge of your circle, if you were to connect 2 points that does not pass through the center, let's say I pick 2 random points and I draw a line. Okay, you call a line like this a chord. So this is just a chord that's running through my circle, and then the diameter is a special chord that runs through the center and goes all the way across. All right, so if I were to take now, go along the edge, and go along what I would say is like the perimeter of my circle, but only half of it. So this little half right there, that is what is called a semicircle. Semicircle. So it's half of it. And then we have another special term, which is just the center and is really how you make a circle. And you go in any direction all the way out to the edge. And this is called the radius. Now the radius is in essence what defines your circle. So that's the one that you take that distance and you rotate it all the way around your center, and there you go. That's your radius. So we use some special little variables to denote these words. So we have D, always stands for diameter, and you're going to see that a lot in our formulas. You're going to see R, that always stands for radius. And you'll notice the relationship between the radius and the diameter. So the diameter is always going to be equal to 2 times the radius. Or you can also think of it the other way around. The radius is 1/2 of the diameter, always. All right, now over here in this other circle, I want you to put the center again. And we can make, using the radius or some chords, we can make angles within our circle. So I'm going to make first what we call a central angle, which means the vertex of the angle starts at, you guessed it, the center. So there we go. You can make a central angle, and it can be an acute angle. It can be an obtuse angle. So it doesn't really make a difference. Just anything where the vertex is the center of your circle. This is called a central angle. And you can also make some angles where the vertex is along the edge. So I can make a chord here, and I can make another chord there. And now I have another angle, and I would call this an inscribed angle, because this angle is inscribed within that circle. So inscribed angle. And then any connecting point along the edge. So if I were to do that point along the edges of that inscribed angle, and I were to connect those 2 points along the edge, this is called an arc. So this segment would be called an arc. All right, so if we are then rotating around our circle, just as a reminder, circles, they're measured in, or the angles within them, they're measured in degrees. So a full rotation, if you remember, is 360 degrees. A half rotation would be 180 degrees. A quarter rotation, that's 90 degrees, and so on. All right, so the last little bit we're gonna do for this video is this circle here. We're gonna look at a very special relationship that you will see within a circle. And this relationship, I'm sure you've seen it before. It's basically a constant that every circle has in common, and that is the relationship between the circumference of the circle and its diameter. A very special number always occurs. And so I'm going to go ahead and I'm going to draw some markings here, which will make sense to you in just a moment. Here we go. Okay, so for every circle, here we go. I'm going to take this all the way around. The measurement all the way around a circle is called the circumference. So we don't call it the perimeter like we do with polygons. We call it the circumference. And let's see how I do with spelling it. I can never spell this word. Circumference. There we go. The circumference. So the measurement all the way around. So the relationship between the circumference and the diameter. So I'm going to go ahead and draw my diameter. So if I take from any circle the measurement of the circumference divided by its diameter, I am always going to get the same thing. And that number is what we call the number pi. That's where pi comes from. So pi equals 3.14159, and it is an non-repeating infinite decimal, goes on forever. So I just like to go out to those digits, 3.14159, but I'm sure you know more digits. So again, where do you get the number pi? You take the measurements of any circle, the circumference, C, divided by the diameter, D, and that will equal 3.14. So I'm sure you've done investigations with this in lower school, you know, just like measuring different circles, where then you find the circumference, you divide it by the diameter, and you do it with a couple of objects, and you see that relationship always comes out to be the same thing. So the circumference, generally speaking, is going to be a little bit more than 3 times the diameter. So I'm going to write a little note here. This relationship is constant for every circle. For every circle. There we go. All right, so we're going to stop there, and then we have a couple other videos for the formula for this, finding the circumference and the area.